Welcome, everyone. The summit is now live. David, please take it away.
Thanks, Allison. Okay, welcome, everyone. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the first session of today's summit, Future-Proofing Your App Infrastructure in the AI-Ready Hybrid Cloud Era, Financial Industry Edition, brought to you by A10 Networks. Before we start today's event with these two great sessions, we do have some announcements. First, we want to let you know this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days. Each of today's two sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up so we can get them answered for you by our experts. Also, during today's second session, we will be giving away $300 Amex gift card, but you must be present to win, so be sure to stay on for the entire event. Finally, we do have resources from our sponsor, A10 Networks, available on the console right now, so please download and check those out. It's because of A10 Networks underwriting this content that we can bring you the summit, so we thank them for supporting the community and ask you to check out those resources so we can bring you more events in the future. Now on to the first session of today's summit. Expert Take, Modernizing App Stacks for AI in a Hybrid Cloud World. This session features Brian Posey, a freelance technology author and 22-time Microsoft MVP. Throughout his career, Brian has written or contributed to dozens of IT books, created numerous full-length video training courses, and published thousands of blog posts on a huge variety of IT and space-related topics. Many of those blog posts can be found in his Posey's Tips and Tricks column or in his Posey's Moonshot column. Brian, it's great to have you here. Please take it away.
Hey, thank you so much, David. Hello, greetings, and welcome, everyone. So today we're going to be talking all about app modernization, specifically for AI integration. And I'll be upfront with you. This is a huge topic. I'm going to do my best to get through all of this and to give you things that you can actually take away and apply. But we do have an awful lot of material to cover. So let me just start with the question of why modernize? Why now? Well, there are three different reasons. For starters, AI is exploding. It's everywhere. Go on just about any website or into just about any application and you'll find AI chatbots or predictive analytics or computer vision or some other AI-powered experience. Now, just to be extremely clear up front with you, I'm not suggesting that you do AI purely for the sake of doing AI. This is something that's been a huge problem in the IT industry for quite some time, is that every time a new technology comes along and it's something that everyone is rapidly adopting, there are always those who do it just for the sake of doing it because it's trendy. So I'm in no way suggesting that you do AI purely for the sake of doing AI. It's important to have a business use case driving that. So with that said, another reason is that hybrid cloud is the reality. You know, a generation ago, the messaging was everything's going public cloud, and if you're still operating on premises, you're a dinosaur. And that turned out just not to be the case. Today, almost everyone is doing hybrid cloud. Very few organizations, with the exception of startups, are 100% in the cloud or 100% on premises. Most organizations are both. And the bigger reason for modernizing right now is that the old application stacks simply can't keep up with emerging technology. For example, some of the old application stacks might be missing the GPU support that is necessary for running AI workloads. Those stacks might be attributed to slow deployments. It might make it difficult to update your applications, or they simply may not be able to scale effectively in order to accommodate AI workloads. So the way that I tend to think of AI integration is being kind of like bringing a new employee on board. And certainly I'm not the first one to come up with this. Microsoft has actually introduced the concept of AI agents that function as virtual team members, performing roles such as analyst or researcher or creator, or in some cases even as admin. Now, I'm not going to be approaching AI quite from that standpoint. I'm not suggesting that you implement AI in a way that takes away somebody's job or anything like that. But there are similarities to adding AI to an application and onboarding a new employee. Because if you stop and think about it, if you hire a new employee today, that employee comes in and they're going to have some basic knowledge on day one. However, they're probably not going to be fully equipped to do the job that you've hired them to do. There's going to be some things that are specific to your company that they're just not going to know yet because they've never worked for your company before, so they don't have that experience. So you're going to have to give them a little bit of training in order to get them started. And depending on the job, that training might last 15 minutes, it might last 6 months. It's going to vary heavily depending on the nature of the job. But there is going to be some training that's required. Now, as that employee gets trained, they're eventually going to be able to do the job on their own. Now, when they first start doing things on their own, they might make the occasional mistake, they might occasionally have questions, but as they gain experience over time, they're going to do a better and better job. Well, AI integration is kind of the same way, because when you initially integrate AI into your application, it's going to have some basic knowledge, but it's going to make a lot of mistakes. It's going to require some fairly extensive training in order to operate effectively. But over time, as you train that AI more and more and it gains a better feel for what's going on, it's going to make fewer and fewer mistakes, and it's going to do a better and better job. So one of the big concepts that I want to introduce up front, and I'm going to do this kind of throughout the presentation, is just introduce some vocabulary that you're likely to hear as you go on your AI integration journey. Training versus inference. It can be thought of as teaching versus doing. Training is the process of, well, training your AI. In other words, feeding that AI lots and lots of data in order for it to learn the patterns that exist within that data. This is kind of like training your new employee to do their job. So as a general rule, the more training data that you can feed to an AI, the better job it's going to do, with one big caveat. And that caveat is that the data that you feed that AI has to be relevant to what you want the AI to do. If you feed the AI data that's irrelevant, you're going to get unpredictable results. The next term that I want to introduce is inference. And inference is kind of like when that employee is now able to do the job on their own. In the case of AI, inference refers to the ability of that AI to make predictions or decisions or to perform a task, because now it's been trained and it's fully operational and it can do things on its own. And the last term that I want to introduce is transfer learning. Now, I'm not going to be going to transfer learning all that much in this presentation, but the idea is that not every AI has to be trained from scratch. Let's suppose for a moment that you've got two AIs that do exactly the same thing. If you've already trained one of those, you can sometimes copy the training data from one AI to the other so that you don't have to train that secondary AI completely from scratch. One way to think about this is that one of the big tests for AI has always been playing chess against a human chess master. And so to initially do that, what these chess-playing robots do is they analyze countless games of chess, and they learn all the different patterns so that they learn how to beat a human. But imagine for a moment that you trained an AI against all of the world's best chess players and got it to where it's really, really good. Now you bring in a second chess-playing robot, and rather than training that robot from scratch, you copy the training data from that first robot. Now the two can play each other, and they can learn from each other, and that will make the robots even better at playing chess than they were when they were only competing against humans. So that's transfer learning. So let's get on to the topic at hand. What does modernizing app stacks for AI actually mean? Well, the way that I like to think about app modernization is kind of like treating your software like a meal. A meal doesn't just magically materialize. There are certain things that go into making that meal. You've got certain ingredients that you're working with, and you've got certain tools that you use in the kitchen. Maybe we're talking about things like plates and utensils. Maybe we're talking about the stove or the oven that you use. There are certain tools that you use, and there are certain ingredients that you use, and all of that collectively goes into making that meal. Well, app modernization for AI kind of works the same way, because you've got certain tools that you use in order to integrate AI into your workloads. So those tools might be languages, frameworks, infrastructure, and you put all of these components into place so that they can effectively run AI workloads. Now, one of the big things that is important to do as you do all of this is to ensure that your application can live anywhere. The application needs to be able to run on premises. It needs to be able to run in the public cloud or in the hybrid cloud. And ideally, that application should be able to migrate back and forth between those environments seamlessly without the need for updating the application. So let's go back to the question of why do apps need to be modernized? Well, as I said, a lot of times the existing application frameworks just don't support AI all that well. So AI workloads usually have some specialized requirements, and I use the word usually because there are exceptions to the rule. But one of the big requirements is that oftentimes they require GPUs. Also, they tend to use specialized frameworks. I'm talking about things like PyTorch, which is an open source machine language framework that's usually used for research and flexibility. Or they might use TensorFlow, which is another really popular machine learning framework. They also need scalable storage. And when I'm talking about scalable storage, I'm addressing the issue of scalability both in terms of capacity and in terms of performance. Now, capacity is important for obvious reasons. I already talked about AI training and how the more training data that you can throw at an AI, assuming that that data is relevant, the better the AI is going to do. So you have to be able to put all of that data somewhere. So capacity is important. But as the AI does its job, presumably it's going to be creating data, so you need capacity for that as well. But performance is equally important, both in the training process and in the actual application running process. So why is that? Well, as I said, AI needs to be trained against vast quantities of data. So let's suppose for a moment that you had an AI model that you're trying to train, and you had, I don't know, I'm just picking a number out of thin air. Let's suppose you had 20 terabytes of training data that you were going to use to train this AI. And because there are very large SATA hard disks, which SATA, for anybody who doesn't know, doesn't exactly offer the greatest performance. It's a legacy technology. So let's say that you dumped all 20 terabytes of training data onto a SATA hard disk. Well, it's going to take a very, very long time to train that AI simply because of the performance constraints associated with that hard disk. Can it be done? Absolutely. It will work, but it's going to take quite a while. Best case, it will probably take 3 or 4 days to churn through all of that data, but depending on what that training process looks like, it could take quite a bit longer than that. So performance is extremely important when it comes to training. But you also need to think about storage performance as your application runs, because your AI-enabled application is probably going to be making decisions in real time based on rapidly evolving conditions. And you don't want your storage to become a bottleneck that inhibits that real-time decision-making. So you need to make sure that your performance is able to meet the demands of the application. So remember, AI workloads can be bottlenecked by inadequate compute resources, just as they can be bottlenecked by inadequate storage resources. Both are necessary in order for the application to perform effectively. Also, old application stacks might not support technologies such as containerization, orchestration, and they might not run at the speed needed for delivering real-time AI insights. And I'll be talking a little bit more about containerization and orchestration as we go along. Starting with orchestration. So orchestration can mean a lot of different things when we're talking about computer science, but in the context of AI, you can think of orchestration as being the conductor of your AI system. It's what makes all of the decisions, and it's what allows all of the various moving parts to work together as one. So in a production environment, let's say you've got an AI workflow. It's easy to think of that AI workflow as just being the AI model. And granted, the model is a big part of that, rather. But the AI model isn't the only component that's used in an AI workflow. There are a lot of other components. So one of those components is the data ingestion pipeline. And this is what pulls in all of the data that AI is using in the decision-making process. And this is going to look different from one application to the next, but it might be pulling in emails, it might be pulling in chat logs or sensor data, or structured or unstructured data. It could be just about anything. Next, we have pre-processing. And pre-processing is one of those things that doesn't really get talked about a lot, but it's an extremely important part of the process. And I've actually got a full slide on this one. I'll come back to this in a little while. But essentially what this pre-processing involves is taking that data that's been ingested and normalizing that data so that it's put into a consistent form, and then applying any necessary business rules and then passing it on. So next we have the AI model, and this could be just about anything. It might be a large language model. It might be a machine language classifier. It could be an image recognition model. The model is going to vary widely depending on what your application is trying to do. So this pipeline ingests data. It cleans up that data through a pre-processing phase, and then it passes that data to the AI model. And then the AI model processes the data that it's been given, and it returns that processed data. Now there's a post-processing phase that has to be completed. And this can involve formatting the response so that it appears in a unified way on the screen. For example, if you're dealing with a large language model, this might be taking the output that was generated and putting it into human-readable text. If we're talking about something that happens behind the scenes, the post-processing might be normalizing the data that's returned so that it can fit neatly into a database. In any case, the format is standardized. Any errors are flagged. It also checks various business rules just to make sure that nothing that has been returned in the output violates any of your compliance mandates or any of the rules that you've set up with regard to how this AI needs to operate. Essentially, it's making sure that nothing gets exposed that shouldn't be exposed. And then the last part is integration with other systems. So this whole presentation is about AI integration. That's where this comes in. So the AI model is integrated with maybe a CRM system or an ERP system or something like that. So there's a lot of moving parts here. And orchestration makes sure that all of these parts run and that they run in the correct order. It also makes sure that data and context are passed between the various components correctly, and that any failures that might occur are handled gracefully without bringing down the entire pipeline. So let's talk a little bit more about orchestration. So in AI systems, and in particular large language model systems, orchestration keeps track of the conversation history and the user context. So why is this important? Well, most of the large language models that are out there are stateful. In other words, they remember past conversations. But there are stateless models out there so that you can enter a prompt, the AI will respond to the prompt, but it has no memory of the conversation prior to that point. And this can have its advantages, but it can also get a little bit messy because if you ask the AI to elaborate on something that it just said, it won't be able to because it doesn't even remember what it just said. So a big part of orchestration is handling that past conversation in order to remember what has been said previously and in order to give context to the conversation. So something else that orchestration does is it injects system prompts, policies, corrections, and constraints before sending the data to the model. And this is super important. You never ever, especially in the case of a large language model, you never ever want to send a raw prompt to the AI. Now, what do I mean by that? Well, let's suppose that you've got an input field that's exposed to your user, and the user can type any question they want, and then that gets sent up to a large language model that that returns a human-like response. Well, you never want to capture what the user said and send it directly to the model. Instead, what you want to do is do some pre-processing on that user input. And what that pre-processing does is it cleans up what the user has sent. One of the really important reasons for that is that this helps to avoid prompt injection attacks, because there are ways that a user might be able to structure a prompt as a way of compromising the AI and getting it to expose data that the user shouldn't have access to, or even accessing the AI model on the back end. So you've got to do some cleanup on the prompt. Also, sometimes the user will enter something that has a lot of misspellings or that is ambiguous. So part of this cleanup process is correcting those sorts of things so that the model that is going to be answering the user is able to make better decisions. So if you correct the user's spelling errors and you try to add a little bit of flavor behind the scenes to what the user is asking, well, the AI is likely to do a better job of returning a good answer. So something else that the orchestration process will typically do as a part of this is to choose the AI model that should be used to generate the response. So let's go back to a situation where you've got a large language model and there's an input box that the user can use to enter text, and then the large language model responds to the user's question with a human-like response. Well, that user could ask just about anything. You don't know what the user is going to ask. And some questions are going to be a lot more complex than others. So what you might do in a situation like this is have a secondary AI model that does nothing more than figure out which AI model is best suited for answering the user's question. So if the user asks a really simple question like, oh, I don't know, who was the first president of the United States? Well, that's something that's really easy to look up. It's something that the AI should be able to know without really having to give a lot of thought to it. So in a situation like that, your orchestrator might pass that query off to a smaller AI model. If the user, on the other hand, were to ask something really, really complex, well, then that query might need to be passed off to a reasoning model. So this raises the question of why not just use one really big model for everything? Well, having separate models can, one, make sure that the users get the best response possible. Two, it helps to reduce the load on your system. Because if you're not using your really big models for every single prompt, well, you're not going to need quite as many computing resources. Now, these orchestration workflows, yes, they're part of the application and part of the general AI usage process, but they can also be used for security, particularly with regard to AI workflows. So let's suppose, for example, that you set up an AI that's designed to look for phishing attacks within your email system. Let's take a look at what the orchestration engine might do in a situation like that. The first thing that it might do is if an email message is flagged as being suspicious, it might run that email through a phishing classifier. And that classifier could then return a confidence level as to how confident it is that this particular message is a phishing message. So if the confidence is low, then what it might do is pass that message off to a different AI, maybe a large language model, to interpret the possible intent. What it can do then is to combine the results with other sources of information. Maybe the company has a block list, and it can look at all of these various sources of information and then make a decision based on all of the information that's available to it, and then pass that information to the email quarantine service. So all of this is to say that orchestration makes sure that all of the necessary components run and in the correct order, but it also provides guardrails. So let's suppose for a moment that you've got an application that consists of a number of different scripts, and each one of these scripts performs a discrete task. All of these tasks have to be performed from time to time, but not every task is being performed all of the time. With orchestration, you can control which scripts get run and when in response to changing conditions. You can also automate complex multi-step tasks even across entire departments. You can ensure consistency, in other words, making sure that the exact same steps happen every time with repeatable results. And that's one of those things that's easy to gloss over, but this is another one of those things that's really important. Because I mentioned a moment ago that there are stateless AI applications that are based on large language models, and that those particular applications retain no memory of previous conversations. One of the really interesting things about some of those, and I'm not talking about every application that falls into this category, but at least some of them that I've seen, is that because they have no memory of previous conversations or even previous elements of the conversation that's going on right now, they can give you completely contradictory results. If you were to ask the AI a question, it might give you an answer, and then if you were to repeat the same question, it might give you a completely different answer that contradicts the original answer. So orchestration helps to keep that from happening. It can help to make sure that the same steps happen every time and that you get consistent results. So that's one of those things that's really important with regard to AI-enabled applications, because you don't want your application to just go off the rails. You want it to perform and behave in a very consistent manner. Another thing that you can do with orchestration is you can monitor, log, and audit all of the decisions that AI makes. So that way, if something is happening that's really bizarre, you can at least go through the logs and figure out when it happened and why it happened and get some sense as to what's going on. And then maybe at that point, you'll find that more training is needed or that the AI model needs to be fine-tuned a little bit to keep that from happening again. But being able to monitor and log and audit all of the decisions is something that's super important so that you can track down what went wrong in those types of situations. So another way of thinking about this is to think of AI as being the brain and orchestration as being the nervous system. It connects the brain to the muscles and the organs, and those are the things that actually do the job. In this particular analogy, those muscles and organs might be things like scripts and containers and code snippets and things like that. So let's talk about orchestration from a financial services standpoint. Here's an example of how orchestration might work. So orchestration might pull the latest transaction data every minute. Then the next thing that it would do is clean it up and remove any entries that are obviously invalid. It would normalize that data, put it into a known format, and then send the data in batches to a predictive model. So at that point, the AI would cross-reference any flagged transactions against a rules-based fraud system. And if there's high risk detected, it might automatically notify a human fraud analyst and then log all of the actions for a compliance report. And the nice thing about this is that all of this is automated, repeatable, and traceable because of the orchestration engine. So let's talk a little bit about hybrid cloud. In other words, why use hybrid cloud? Well, hybrid cloud allows you to run workloads where it makes the most sense to do so. Because remember, with a hybrid cloud, you've got elements that reside on premises, and you've got elements that reside in one or more public clouds. So what you might do in a situation like this is to train your large models in the public cloud using elastic GPU clusters. And the reason for that is simply because a lot of times there's going to be more compute resources available in the public cloud than there are on premises. So you can take advantage of all of that extra capacity in the training process as a way of speeding up the training. And what that does for you is that if you can't deploy this new version of your application until the training is complete, well, speeding up the training process allows you to ramp up the deployment process and deploy the application a lot more quickly. You might also run inferences locally, and you might do that as a way of controlling costs because you're not doing those in the public cloud where every transaction is incurring cost. But more importantly, you might be running those inferences where they're in closer proximity to the end users who are actually going to be working with the application, thereby giving the end users a better experience. Another reason to use the hybrid cloud is because you can take advantage of containerization. So if you run applications or even microservices inside of containers, you can move those containers around as needed. You can run it on premises, you can move it to the public cloud, you can move it back on premises. So the applications can move freely between environments as your business needs dictate. This also helps with application resilience because if you have an outage, you can move an application to a different location where it can continue to run. Now, one of the things that I would recommend with regard to application resilience is to just make sure that you're storing copies of your models and your data anywhere where the application could potentially run. Because let's suppose for a moment that you're keeping a copy of your model and your data on premises, and your application is also running on premises. Now you have an outage, so you move the application up to the public cloud. Well, moving the application to the public cloud isn't going to do you any good if the system that is storing the model and the data is on premises and you're having an outage. So having a copy that's also stored in the public cloud will allow that application to continue to function once the application is moved up to the public cloud. Now, at the very beginning of this presentation, I mentioned that it's important to do AI integration because it meets a compelling business use case, not just because it's a trendy thing to do and everybody else is doing it. So it's important to make a business case for application modernization. So modernization isn't just about making your application run more quickly or adding AI to your application. It's really about future-proofing. We want to make sure that that application is going to meet all of your future needs and not just the needs that you have right this minute. So this is where hybrid cloud comes in again, because hybrid cloud gives flexibility to AI, and that AI in turn can help to give businesses a competitive edge. It's been said that organizations that modernize now are going to be the ones leading in predictive decision-making, customer personalization, and operational efficiency tomorrow. In other words, there's a competitive edge for those businesses that use AI effectively. So let's talk a little bit about the current state of applications. One of the big things that's driving the need for application modernization is legacy application stack limitations. So what are those limitations? Well, One of the limitations is a monolithic architecture. In other words, you may have an application that resides as one great big chunk of code. So applications like that certainly can work. They've worked for decades, but they're not the easiest thing to update. That tends to lead to slower release cycles, and it's hard to add new features. So instead, you might consider breaking that application into microservices, so that way you can update the microservices that need to be updated rather than having to sort through an entire great big block of code. Another limitation that is associated with monolithic legacy applications is limited scalability. A lot of existing applications just really aren't designed to scale. So if you're modernizing the application, that gives you the opportunity to engineer it in a way that allows for scalability. So if you have an increased demand, well, then maybe you can deploy additional instances of that application as a way of handling that extra demand. Another limitation is data silos, and this is something that exists in most organizations where data is isolated. The big problem with that is that AI thrives on data, and in order for AI to really do the best job, it needs access to as much data as you can throw at it, with some obvious limitations and caveats. So it's important to break down those data silos as you're looking at ways of integrating AI. Now, if we start talking about the typical hybrid cloud architecture, as I said earlier, the hybrid cloud allows you to run workloads where it makes the most sense to do so. So if you've got a latency-sensitive workload, or if you've got a workload that is highly regulated, well, then maybe it makes the most sense to run that particular workload on premises. On the other hand, if you've got a workload that requires vast scalability, that might be better suited for the public cloud. So the hybrid cloud lets you move these workloads around where it makes the most sense to run them. So one potential real-world example is that maybe you've got a healthcare provider that keeps patient data on premises because they're required by compliance mandates to do so, but they take that patient data, they anonymize it, and then they send that anonymized data up to the cloud where it can be used to train an AI model. So I think this would be a good point to stop and talk a little bit about application migration, because application migration is actually kind of a big point or a big part of the application modernization process. Because typically, if you've got an old legacy application and you're going to be modernizing that application with a new stack and modernizing it to take advantage of AI, that application is probably going to end up running somewhere else. So there's something called the 6 R's of application migration, and I'll tell you up front that there's a million variations on this. I've seen some lists that have 7 R's or 8 R's, and sometimes the names are a little bit different from one model to the next. But here's the general idea. There's 6 words that all start with the letter R, and they refer to types of migrations that you can perform. The first one is called rehosting. This is sometimes called a lift and shift migration. This basically involves just picking up an application and moving it to a new environment, making extremely minimal changes along the way. So as an example, this might be taking a virtual machine that's running on VMware and then moving that virtual machine up to the AWS cloud. You haven't really done anything inside of the virtual machine. All you're doing is picking up that virtual machine and moving it to a new environment. The next R is replatform. This is sometimes referred to as lift, tinker, and shift. It's like rehosting, but the difference is that instead of having the goal of not changing anything, you make really small optimizations along the way as a way of taking advantage of the new platform. So let's say, for example, that you've got a database application and you're migrating that database application to the cloud. Rather than continuing to run that database inside of a virtual machine, you might take advantage of a cloud-based managed service so that way the cloud provider is now handling all of the tasks associated with managing the database server and keeping it patched and up to date and running and all of that. So you no longer have to deal with that sort of thing. So at this point, you haven't really made any changes to the application. The application still works the same way that it always did. You're just running the database in a different way. So that's replatforming. The next R is repurchasing, and this is sometimes called drop and shop. The idea here is that you're trading an application that's no longer meeting your needs for a different application that does. And there can be any number of reasons for doing this. there might be a new application that has some features that you'd love to take advantage of. You might find that there is now an undesirable licensing model. For example, if you bought what you thought was a perpetual license and the vendor is now going subscription only, that might be a reason to look for a different competing application. Another example might be you just want to go to a SaaS application and run that application in the cloud rather than running it on premises. In any case, the essence of this is that you replace one application with a different application. And of course, when you're performing this type of migration, you have to think about how you're going to get your data from the old application into the new application. The next one is refactoring. And refactoring is the model that we're going to be talking about most often when it comes to modernizing an application to take advantage of AI. So refactoring is the most complex and typically the most expensive of all of the models that I'm going to be talking about, but it essentially involves redesigning the application to take full advantage of its new of its new platform rather. This might mean taking a monolithic application and breaking it into a series of microservices. The next R is retiring. This is essentially just decommissioning an old application that's no longer useful or cost-effective. And it's also sometimes done if you have applications that have overlapping functionality. Let's say you've got 3 different applications that all kind of overlap with each other. Maybe you can retire one of those applications, thereby helping to reduce cost and complexity within your organization. And then the last of the 6 R's is retain, or revisit later as it's sometimes called. And this one is essentially just don't do anything right now. Let's revisit in 6 months and just see if things change or if there's still a need to do something with this application. So what does modernizing for AI really mean? Well, for one thing, there's a shift from monolithic applications to microservices and API. So this allows AI services to be integrated as separate modules. So that way you're not writing great big additions to monolithic code. You're simply creating a module that your code can plug into. And this makes your entire application modular, and it makes it a whole lot easier to update that application with new functionality in the future. For example, if you've got a banking application and you need to do fraud detection, you might create a fraud detection microservice. And as your fraud detection needs change over time, you can simply update that microservice rather than having to update the entire application. Another thing that modernizing for AI typically means is adoption of containerization and orchestration. So typically Docker and Kubernetes are going to be the go-to solutions for that. And then it also refers to event-driven architectures. So when you modernize an application to take advantage of AI, what you're really doing is you're designing a system that can respond in real time to AI-based predictions. So another really important consideration when you're modernizing an application for AI is where does the data live? Because remember, data is at the heart of every AI-driven application. Data is needed for training, but at the same time, your application also produces data. So typically, you're going to be dealing with large volumes of data, both at runtime and during the training process. And in many cases, the training process is ongoing. So where does that data live? Well, you could store the data in a single database, maybe a SQL server or on a service such as AWS RDS, which is a database service in the Amazon cloud. Another possibility is to use a data lake. And for anybody who's not familiar with that term, a data lake is just a storage system that can hold raw data. And that data can exist in a variety of different formats. It could be structured data, such as a database. It could be unstructured data, such as files. You basically just dump all of your data into this lake, and it stays there until it's needed. Another alternative is a data warehouse. It's kind of like a data lake, except everything is a lot more organized. The data is normalized, it's sorted, it's put into a format that makes it ready to use at any given moment. And then there's another term that's a lot less commonly used, but it's something that seems to be gaining a bit of momentum, called a lakehouse. And a lakehouse is kind of like a cross between a data lake and a data warehouse. And basically it's a hybrid. It combines the flexibility of a data lake with the organization of a data warehouse. So what are the requirements for accessing that data? We've talked about where the data lives, but how do you access the data and what's needed for data access? Well, the most important thing is a high bandwidth connection, preferably a redundant connection. Now, redundancy isn't technically a requirement, but it is a practical requirement because if you have a link that goes dead, you don't want your application to go offline. So it's important to have that redundant connectivity to keep that from happening. So another thing that I would recommend having as a part of your data access is an ETL engine, ETL being extract, transform, and load. So ETL is the process of pulling data from a source, cleaning it, transforming it, and storing it in a usable format. And this comes into play especially if you're using a data lake, because remember, a data lake has data that's unsorted and it's just kind of random. So you need to put that data into a usable format before you try to do anything with it. Now, some might be quick to point out that this is a lot less important than it used to be in the age of AI, because a lot of times AI can make sense out of raw data that hasn't been sorted or normalized in any way. But what I would say is that even if that is technically possible to do, I would still recommend taking the extra step of normalizing your data before you feed it to AI, just because you're a lot more likely to end up with better results if you go ahead and do that. Because if you're taking raw data that hasn't been normalized in any way and you're feeding that to AI, AI might be able to understand that data, but there's a greater chance that AI will misinterpret the data and take it to mean something that it really doesn't. So you improve your odds by going ahead and performing that data normalization before you hand the data off to your AI model. So what about compute requirements? Well, when it comes to compute requirements, the biggest things that you're going to need are GPUs and TPUs. GPUs are graphical processing units. They're essentially video cards. They were created originally for video use, but they're really good at performing parallel computations, and that makes them ideal for use with AI workloads. Now, a TPU is a tensor processing unit, and this was a custom AI chip created by Google, and it's even faster for certain machine learning workloads. So something else to keep in mind with regard to computing requirements is that it's a good idea to structure your AI workload to be able to burst to the cloud. So in other words, if your workload sees an increased demand, your on-premises hardware may not be readily available to meet that demand. So you may be able to burst that workload to the cloud as a way of making sure that the demand is handled. So what are some more workload considerations? Well, data locality for compliance and latency. In other words, you may have requirements that mandate that your data is stored in a certain location. So that's certainly something that you need to keep in mind. Also, keep in mind data privacy. There's certain data that you probably don't want to hand off to AI. And if you do hand that data off to AI, you need to make sure that it's handled in a responsible manner and that that data doesn't leave the boundaries that you've set up. Also, networking. We've talked about high bandwidth, low latency links and the need for link redundancy and the elimination of data silos. And then, of course, security and governance is always a consideration. It's important to apply zero trust principles and to classify your data before moving that data to another workload. So what does the modernization roadmap look like? Well, there's the assessment phase. That's basically inventorying all your apps, your workloads, your data sources. Then you move on to architecture redesign. So this involves choosing your hybrid deployment model. What's the architecture of that application going to look like? Is it going to be hub and spoke, cloud adjacency, edge integration? Then you have to focus on your data strategy. This means building unified data catalogs and pipelines, taking steps to eliminate data silos, and more importantly, taking steps to make sure that AI doesn't gain access to anything that it shouldn't. From there, you move on to platform modernization. This is migrating to containers, orchestrators, and CI and CD pipelines. And for anybody who is not familiar with those terms, this is continuous integration and continuous deployment pipelines. Then you start integrating AI. And my recommendation here would be to start with a proof of concept model and then build off of that rather than trying to do everything all at once. Your development experience will probably go a bit more smoothly if you do adopt the proof of concept model. And then finally, monitor application performance, retrain the models as needed, and refine your architecture until you're getting the best possible experience. Now, there are a few different pitfalls associated with AI workloads. One of the big ones is underestimating data integration complexity. I'm not going to lie to you, this can be a very complicated undertaking. Another pitfall is over-reliance on the cloud, leading to unpredictable costs. This is something that we see all the time, even with non-AI workloads. Neglecting change management for the development teams, and model drift. And model drift is the last thing that I want to talk about because I'm just about out of time. But it's something important, so I want to at least touch on this briefly, just for anybody who might not be familiar with this. So machine learning model drift is what happens when a model's performance declines over time. And the reason why this happens is because the real-world data that the model is seeing is different from the data that the model was trained on. And this is something that happens in the natural evolution of many applications. You know, things change over time, and if your AI wasn't trained to recognize those changes, well, then it's not going to know what to do with the data. So what can happen if this drift isn't detected and corrected? Well, best case, performance is going to decline because the AI has to, and I hesitate to use this word, but think about how to handle it. So it's going to have to give a little bit more thought to what to do with the data in order to make a decision, and that's going to cause it to slow down a little bit. More typically, though, predictions become inaccurate, and any business decisions that are based on those predictions can suffer, and in some situations there could even be compliance risks. So there's three main types of model drift. There's concept drift. This might be a situation where a fraud detection model trained before a new type of scam emerges, and so it doesn't know how to deal with that scam because it was never trained on it. There's also data drift. So this can happen if, say, a product recommendation model trained on last year's customer demographics, but now you've got completely different types of customers who are visiting your site, and the AI doesn't know what to do with that. And then there's label drift. This is what happens when the meaning of words change. So maybe there's a financial situation that gets labeled as high risk, but it wasn't high risk before, so it kind of confuses the AI model. So how do you prevent model drift? The biggest thing that you can do is alerts. So trigger notification if performance begins to decline or if you start getting unexpected results. Periodically or automatically retraining the model using fresh and representative data. That's probably the number one thing that you can do to prevent model drift. And versioning. Keep historical models. Don't just throw away your old models. Keep them on hand because sometimes you may have to revert to a previous model. And keep your previous data sets as well. So other AI best practices, develop DevSecOps for all AI projects. Align your AI efforts with clear business goals. Don't just do AI for the sake of doing AI. And monitor both machine learning model drift and infrastructure performance, just to make sure that nothing drops off. So with that said, I'd like to go ahead and open it up for questions.
Okay, we'll do that. First of all, great presentation, Brian.
Thank you.
And now let's get to those questions. First, I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So send them on in. And let's get to those questions. I'll take them first come, first serve, Brian, if you want to follow along. So that would be from the bottom up in your Q&A console. So let's get to the first one. Is it possible to do AI without GPUs or other specialized hardware?
Is it possible? Yes. Is it recommended? No. The reason why I say that is because AIs are extremely computationally intensive, and the GPU allows for that parallel processing that AI workloads really need. Now, you can offload some AI workloads to a traditional CPU, but there's going to be a huge performance hit. I did a test on an AI model maybe 6 months ago, and I found that when I used the GPU, this particular model completed a task in roughly about 2 minutes. And when I tried to perform the same task using only the CPU, that same task took upward of 5 hours. So the GPU can make a big difference. So is the GPU absolutely necessary? No, but it's best to use it if you can.
Okay, great. Next question reads, if I am hosting an AI app on a virtual machine instance, does the need for a GPU impact virtual machine portability?
Oh, that is a great question, and yes, it does. Keeping in mind that every virtual machine platform works a little bit differently. But let's say that you've got a virtual machine that's running on, I don't know, Microsoft Hyper-V, and you've dedicated a GPU to that virtual machine. Well, at that point, if you try to live migrate that virtual machine over to another server, and that server doesn't have the GPU resources that can be allocated to it, well, that live migration is going to fail simply because you don't have GPU resources on the other virtualization host. So yes, dependency on specific hardware absolutely impacts virtual machine portability.
All right, great. And Brian, towards the end, you talked a lot about model drift. And here's a question on that. Is model drift something that happens to all AI applications?
No, it doesn't necessarily happen to all AI applications. It primarily happens when the nature of the data begins to evolve. Let me give you a really simple example. Let's suppose that you're operating a retail environment, and you've created an AI that keeps track of how long customers spend in your store on average. Well, as long as customers keep coming into your store, that model is going to keep on working. You're not going to have to worry about model drift. But let's suppose that you start accepting online orders, and customers only show up, pick up their online order, and they're on their way. They never even set foot in the store, or if they do, it's just long enough to pick up a bag of whatever they've purchased. Well, that's probably going to cause some major problems because your AI was trained before you started doing those online orders. So that would be an example of that drift that occurs. At that point, the model would need to be retrained to recognize a new situation. But as long as the situation that the model was trained on doesn't change, and the data that's coming in still fits the profile of what the model was trained on, you're not going to have to worry about that drift.
Okay, good to know. Let's try to get through as many of these questions as we can in the next 5 minutes or so. Okay, here's the next question. What is one quick win financial institutions can achieve when starting to modernize legacy systems without disrupting daily operations?
What's a quick win that they can achieve by modernizing applications without disrupting anything?
Yeah,
I would say one of the biggest ones is that it just makes the applications a lot easier to maintain. Even if you take AI out of the picture, just breaking those applications into microservices and containers, if you have a problem, your patch management process is going to be a whole lot easier. It's going to cost a lot less to maintain the application, and you gain application portability in the process. So those are a few quick wins.
Okay. Next question reads, how can financial institutions ensure AI model training and deployment remains compliant with industry regulations like SOX or GDPR?
All of that really comes down to data classification. What I would recommend is before you ever begin training an AI model, take the time to classify all of your data, maybe apply tags to the data so that way when you're training your model, you can make it recognize those tags so that if it encounters certain types of data, it knows that it can't touch that data and won't include that within the AI model. And that reduces the chances of the model returning something that it shouldn't to an end user and exposing something that's going to result in a regulatory violation. The other big thing that you should be doing is just working on your orchestrator to do data sanitation on both the user input and on the model's output. So you should be checking what the user has inputted just to make sure that it's not violating any of your business rules and that it's not going to do something that's going to harm the AI. But you also need to be checking the data that's produced by the AI and making sure that that output isn't going to cause any compliance violations. And if something gets output that shouldn't, you can deal with it right then and there before it's ever exposed to the end user.
All right, great. Looks like we have time for one more question, depending on the length of the answer. And the question reads, what role does zero trust architecture play in securing hybrid cloud environments, specifically for the financial sector?
Well, the idea behind zero trust is that you don't take anything for granted. You always verify identities, and we're talking about user identities, and we're also talking about machine identities. So I wouldn't necessarily say that that's something that should cause anything to be radically different with regard to adopting AI, because that's something that you should already be doing. And I would also add to that least privileged access. End users shouldn't have access to anything other than the bare minimum of what they need in order to do their jobs. And the same goes for AI. I mentioned during my presentation that in some ways you can think of AI as being almost like onboarding a new user. Well, if you're onboarding a new user, you're not going to give them access to every bit of data that the organization has. You're only going to give them access to what they need. And you should be treating your AI models the exact same way. Maintain that minimum data footprint. Certainly give it the data that it needs in order to be adequately trained, but don't give it access to anything that it doesn't specifically need. And that's going to go a long way toward preserving your zero trust architecture.
All right, great. Well, it looks like that's all the questions we have time for. So thanks again, Brian, for an excellent presentation and answering all those questions.
Thanks for having me.
Everyone else, stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, Vendor Spotlight. So take this chance to grab a cup of coffee while you check out those resources on your console provided by A10 Networks, and we'll be right back.
Welcome back, everyone. John, please take it away.
Thanks, Allison. Hi, everyone. Welcome to the second session of our live online seminar, Future-Proofing Your App Infrastructure in the AI-Ready Hybrid Cloud Era, Financial Industry Edition. This event was organized by the hardworking folks at Redmond Magazine, who have brought together some of the leading experts on today's topic. Many thanks to our sponsor, A10 Networks, for providing, A10 Networks, a provider of secure application solutions for on-prem, multi-cloud, and edge cloud environments at hyperscale. And thanks to you guys for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media. And in just a moment, I'll be talking to the other guy on the screen there, Jameson Utter, who is A10 Security Architect for our Vendor Spotlight. Hi, Jameson.
How you doing today?
Good. Before we get going, I need to do just a little bit of housekeeping. So each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. This session will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Our sponsor has provided some extra resources you won't want to miss. They're available now in your console. At the end of the summit, you'll be asked to take a short survey. We know you guys are busy, but we'd really appreciate it if you just take a moment to share some honest feedback about today's event. And last but not least, at the end of this session, one lucky attendee will be receiving a $300 Amex gift card, but you must be present to win, so stick with us. Now, I want to tell you a little bit about Jameson. He's a veteran security practitioner with more than 25 years in the trenches experience spanning large organizations and small. He's a sought-after speaker who has addressed the EU Congress at The Hague and provided a special briefing for Homeland Security and select members of the U.S. Senate. He is currently serves as a field CISO for A10 Networks. And guys, we are lucky to have him. Okay, brother, I'm going to just jump right in here. Let's go with the big picture. What unique challenges are financial institutions facing today when it comes to app infrastructure and modernization?
Yeah, I think some of the big ones is our push to cloud, in my opinion, doesn't fully favor all financial institutions' needs. Obviously, you know, the hyperscalability, access, that's all good. However, we have an inconsistent run rate for price, right? So it's difficult to build a cost model that tells us, on average, we're going to spend X. Because of surges and other things, DDoSes, all those sort of things sort of can skew that model. And then two other factors really, I think, play into this strongly. And one is AI, which your last speaker had some great information there, and his experience is exactly mine. Everybody thinks they're going to build their AI in the public cloud, and they didn't get the bill yet. And as soon as they get the bill, they change their minds. So we have to figure out how to cost effectively do that. Also, I would point out that the public cloud is not nearly fast enough for actual AI usage, contrary to what they tell you. And the other piece then would be the sort of like dark sector, I guess, of finance, which is high frequency trading, right? This is actually where many investment banks and other things make their money. And we're talking about scenarios where 2 or 3 microseconds can decide whether or not we made that money or we didn't. And that's absolutely not cloud language, right? That sort of speed is it takes you 2 or 3 microseconds to get to your firewall, much less to get out to the cloud and back. So, you know, I think financials have a lot of different challenges in the market today, from the way they have to deploy, who they have to deploy to, right? Vast numbers of APIs, both for internal exchanges, you know, through third-party systems, as well as interacting with their customers downstream. So I actually think they're in one of the tougher segments today to provide technology for adequately.
So latency is a huge deal for mission critical applications in the financial services sector. Maybe say just a little bit about why. I'm thinking in particular real-time transactions and high-frequency trading. Say a little bit more about that.
Yeah, for sure. I do have a slide that we come up with later, I guess, that shows this graphically. But ultimately, when we talk about a trade, we're watching the price of a commodity or stock in real time, and we're attempting to get in at a moment where even at the highest level, some of those trades are the difference between 3 milliseconds and 5 milliseconds might be like $2, right, per share. However, when we add that up, not just for the single transaction, which could be $200,000, $300,000, $400,000, right, depending on the size of our trade and instance, but over the course of days, months, years, this could be billions that we're leaving on the floor. Our traders may have the vision, the understanding, the market insight to move well in the market. However, they're not fast enough. To use maybe an analogy, high frequency trading really more than any other part of their infrastructure is sort of like a race, right? It's like being in an F1 car. And when people will say, well, that 1 microsecond doesn't really matter that much. Well, it's the difference between winning and losing is what it is.
Fascinating. So I'm wondering about organizations that rely on legacy systems. What are some of the hidden costs or risks of trying to bolt modern workloads onto outdated infrastructure?
Yeah, we've kind of hounded latency latency pretty heavily, which still applies to other apps, right? Honestly, like nobody wants to log into their bank and wait. Like that's just not a thing, right? So that's a component of it. But another real piece of it is that when we think about the way that the cloud came to be and hybrid applications, every one of those cloud vendors out there, the hyperscalers, really built their infrastructure in a silo. So if you're deployed in AWS, you use AWS tools, AWS ways, and then if you move to Azure, it's all new. Azure ways, right? Azure security, Azure stack, Azure load balancer, right? And this is true just across the board. They're all like that. And what it can mean is that I can have a team that maybe deals with our web presence, which is spread across multiple vendors, right? This is a part of DORA, if you guys are familiar with the European, right? And I think it's going to hit America because DORA is a pretty good idea. And so now I have like 3, 4, 5 clouds in play, which means I have a team for every cloud because I have different tools for every cloud. And it can become just in that, that's that technical debt that we talk a lot about these days, right? Where we've suddenly we look at the overall cost, right? Which is we kind of did this to save money and time and whatever. And what we did was we backloaded the cost, right? So on the front end, we saved $10,000 by switching to Azure. On the back end, we lost $2 million in headcount and time, right? And so I think that's part of the important part is still, it's not about finding the newer, faster, cheaper version. It's finding the one that works best and most holistically across all those places. Where can I save the 2 things I can't buy in enterprise, which is time and people, right? No company's got the ability for you to hire infinitely, but I definitely need infinite people, right? Like that's just true. And nobody has enough time.
Okay, so you're out in the field having conversations. What are the top reasons financial institutions hesitate to move more aggressively into hybrid or multi-cloud? What are you seeing?
It's always it's risk. I mean, I think this is true universally for all companies, honestly, whatever topic we're talking about, from security to infrastructure, is the status quo, whatever we're doing right now, we have accepted and we understand the risk of whatever it's doing or not doing for us. Even if it's not doing quite a bit and we're aware of it, we are aware of it. We know the situation and we have worked around it for X years or whatever, right? So everything is just like this. And we begin to eye changes or could we get faster? Could we get smarter? But we have to measure that against the idea that what if it doesn't work? What if it goes down? What if we end up in, a worse situation than we're in today? And so the risk of change and the resistance to change is human nature. First of all, it's just right the way I think it's how we survived however many years you think we've been on Earth, right? To become what we are, is that we are in ways risk averse. And then among us are some that are not, right? And those that are not typically don't run financial networks, by the way. right? It's a balancing risk. So I think the key is that companies for years have used lots of hype and scare tactics and things like that to try to get companies to move. And what we have to do is we have to sort of refocus that on what are the actual tangible benefits that you can achieve from this, and how is that going to impact your bottom line today, tomorrow, the next day, right? Over the concept of general risk. Oh yeah, here's my slide. To dip back on this one real quick, so you guys know what I'm showing you here. So this is a speed and number of races. That's what they actually call high frequency trades, by the way. It's measured in races. And more than 20% of the volume this is from London, right? So this is the London Stock Exchange, are high frequency trades. And so when we think about that, that's a massive amount, but the biggest percentage of them are happening within 0 to 15 microseconds, not milliseconds, right? Microseconds. And so that means that if I'm coming in with a trade from a normal network that's measured in milliseconds, I'm coming in all the way at this 400, 500, right? We're coming in down there. It means I lost every race, right? So that's just to give a kind of a sample. The bar graph represents number of races at that time interval, right? So most of the traffic happens in a 0 to 15 microsecond window to win at a high frequency trade.
Wow. So in the context of hybrid cloud, how should IT teams rethink application delivery architecture to accommodate both legacy and next-gen workloads?
Yeah, I think, when we start to think about that, we have to sort of put together three important concepts that is our essential job, right? As security folks and IT folks. It's fascinating to me, just as a quick sidebar, that I often hear now business outcomes have become a priority. I'm like, they have always been the priority. This is why we're here. It kind of makes me sometimes a different kind of practitioner, because I have a viewpoint that as a security person, I am not a cop. I'm not here to catch bad guys. I'm here to protect the business. I'm a bodyguard, not a cop. I actually don't care if hackers or attackers are doing things that don't affect the bottom line. It's not relevant to me. What's relevant is are we operating the way we are meant to operate the business, making the maximum profitability and ease that we can. So it's kind of like a paradigm shift, right? So when we think about that, part of that is, can we do it quickly? Can we do it highly availably, right? Are these reliable technologies, reliable methods, proven methods? We have to do that across all these environments now. And sometimes I might say on-prem, and what I mean by that is self-hosted. Right. It could be in the cloud. It could be anywhere. It just means this is under your control or under a hyperscaler control. Is really my dividing line for those concepts. On-prem doesn't necessarily mean a box in the closet. It could be your own cloud, right? And really, out of all of that, we have to combine the need to secure the data, both against actual theft and attack, as well as reconnaissance style attacks, where there's a large market on the dark web for data correlation. So I got a list, say, of people and phone numbers. That's all I have. And I will contract someone else to help me fill in the blanks. Give me their home addresses. Give me what kind of car they drive. Give me their credit history. Give me, right? So I'm trying to build this profile of who they are. And I need more data, because once I get the whole profile, that's worth good money, right? A name and a phone number is whatever, they're pennies on the dollar, right? So they may do something, for example, in the financial world, where we're thinking that overall the cookie jar is them getting into the financial data and siphoning their bank accounts. But what they really came after was their home addresses. What they really came after was just this other nugget, because that system, whatever that was, is easier to get to than trying to steal the cookies directly out of the cookie jar. Right. And I'm not saying there aren't people trying to steal. There, obviously, all of these attacks are happening at once. But sometimes there's different types of things going on that are difficult to correlate from one avenue to another place to another. So I think that's part of the conversation here about how do we manage this, is we have to look at it holistically. We can't say I have a cloud strategy, I have an on-prem strategy, I have a hybrid cloud strategy. We have to look at it as one funnel, that what is the best answer for user experience that combines security, latency, and availability.
Okay, AI is on everybody's mind now, obviously. So so talk about what does an AI-ready infrastructure really mean for financial institutions? And what are the prerequisites they often overlook? Maybe.
Yeah, I would say the first one is compute. Like that's usually the first one. Every conversation I have, and we have a whole series where I'm traveling the country speaking to leaders in these fields over a dinner, and we're talking about how they're doing what they're doing and what their goals are with AI, and many of them are spinning their instances up in a hyperscaler, using their tools and their compute, not necessarily realizing because of where they are in scale that this is going to be costly to do so. And it's also not really fast enough. Not really. I can use it to build a report, sure. But if I want real-time transactions, the cloud was never meant for real-time. That's not, right? We have latency going to it, much less whatever's going on inside there. I don't know if I believe or disbelieve Amazon that they can do, microsecond transactions, but I can't get to them in a microsecond, right? And so, we're not always thinking about the needs of the application that we're trying to run, because ultimately AI is a new application, right? It's not a new everything. It's a new application we're using to do a lot of different things, kind of in a sense like a new SAP or something, right? Mm-hmm. And so the mistake I see the most is we haven't thought about how we're going to be able to build this into a data center we control with massively powerful GPU-powered devices, with all the right safeguards under our control physically, and then if we have to, burst that out to the cloud, or in some other cases, vice versa, until they get the bill, and then they'll switch around the other way. But that's part of what I'm seeing, is not this understanding that from a compute power and latency perspective, it's a new world. We have never experienced something that is so reliant on latency. Like your last caller talked about, like the SATA disks are no longer useful. They're way too slow, right? And it's considerations people don't think about. In the old world, right, we would build a giant RAID array of all these disks, and that'd be great. But a 1.5 millisecond search time is no good for an AI.
Right.
And so that's the fundamental piece, is beyond any of the business problems that I see them not addressing, is the architectural problems of, okay, assuming we're going to do this, even if I don't know why, how are we going to provide that service in a customer friendly format? And even if we're not providing it to our end customers, even if it's internal, right? I'm expecting my people to use this to make us smarter and better and faster. What does delivery day look like? What does that infrastructure look like? How are we measuring the ROI based on speed, right? Output, availability? They're not thinking that far down the road yet.
Okay, so let's talk about observability. How does it play into optimizing app delivery across hybrid environments?
Yeah, I think observability is first of all a massive buzzword. Right. But I do think it's important, more so than the concept of observability. It's really, and I have this thesis in general about visibility in the network space, is why and what are we doing with that? I gave a presentation at Black Hat last week or week before, whenever Black Hat was. I forgot. And in it, I have a video of a guy stealing a package off of a doorstep, right? And I said, this is visibility in the enterprise. I watched you steal it. Okay. but what did I do about it, right? What did I
Right.
do with that observability? And so I think that's the key to observability. The old adage of you can't protect what you can't see is actually a fallacy.
Hmm.
There are, to quote Donald Rumsfeld, there are known knowns, there are known unknowns, and unknown unknowns, right? And we protect every day against unknown unknowns. Those are always the ones that do eventually get us. But your firewall, just as an example, protects against things it has no idea what they are. It doesn't care, right? So we don't need to see everything to protect against many things. What we need to see is how are our systems impacting each other.
Mhm.
So for example, just to use a security, example quickly, is typically what we see in like security systems for financial is you've got these four basic functions, right? I have to protect web traffic, I have to protect API traffic against bots, against DDoS, and we feed all of that into the SIEM. And the SIEM tries to take that moment of observability and create a picture for us. And that has failed because the HTTP part doesn't know what the API is doing. And the SIEM doesn't know what it means for either of them to be doing that, right? It's simply doing data correlation blind, very similar to just feeding it into ChatGPT and hoping for the best, right? And so what we really need is systems that are able to use cross observability. So whether we're thinking infrastructure, right, predicting what's next and where it is and where the delays are and who's lagging, and right, because always there's a chain of devices and systems that create the end product, right, the customer experience. So the observability has to be linked to an understanding of context for how did we get from 0 latency to 300 milliseconds? When and where did that happen in the chain, and why? Is this system putting out a packet that's weird and it made that system slow down? Not just that system slow, because there's usually a story for why that system's slow, right? So to me, that's the observability chain that we have to make sure that we're addressing holistically.
So how do cloud-native approaches change the way we think about scale, especially for transaction-heavy workloads?
Yeah, I think we have to start to understand that really what we have in our enterprise is compute. That's what we have. Cloud, on-prem, whatever. It's compute. And we need to price and think of them as the cost of compute. Meaning we host these and it costs us X a year in power and cooling and staff or whatever. And then we have this burstable ability to the cloud where we might offload more power, or in generally we get power from there, whether it's like if it's a website front door or something. But we need to really stop thinking about data in the old way, storage and throughput, and we need to think about it as dollars. How many cents a second does this compute cost over this compute? And then we can begin to really build a picture, because really what we're looking for is and again, just to use another one of my slides I brought, and it's a security concept, but this works holistically, right? Even for network, is that what I really have is a network that spans multiple functions, whether that's on-prem, off-prem, right? Load balancing, DDoS, I have all these functions. And instead of thinking them as individual silos as part of a bigger thing, think about the thing. What am I providing, right? I'm providing a banking application, for example. And so what does that end user experience mean? Start with the end. At the end, it should look like this. And then back up through it. Like, how do I provide that? How do I provide that? How do I provide this, right? And build that chain. And then instead of measuring it necessarily in bits and bytes and throughput, measure it in dollars, because that's ultimately, right? Revenue is the one thing that's on every executive's mind. And I don't care where they work in the company, right? Is how do we build revenue? So measure it in dollars and cents, whether that's per millisecond trades lost, whether that's seconds of wait time on a banking application on my phone that makes me pissed off and I change banks. Measure it that way. That a lost second is X dollars.
Measure it in dollars. Okay, how can infrastructure teams identify and address the root causes of latency in financial transaction systems? I'm sure. Go ahead. I'm sorry.
Yeah, no, all good. I didn't know if you had more color there. I, I think that, well, the first thing is let's see, you blame the network, and then you blame the application, and then you blame DNS, and then right. So ultimately, see, I've been in IT for a while.
Yeah.
But really, what it comes down to is what we have to understand is what is the impact of that performance. Remember, I said measure in dollars. So now I actually can have an impact to what that means. And then as I walk through my chain to understand, is the pipe correct? Meaning, can I flow enough data at the right speed, regardless of what's happening? Then I begin to look at, as I was talking before about the observability problem in making this a chain of events, as I could begin to track the app's performance across the chain. How does it perform here? How does it perform here? Right? Because the problem could be multifold. Meaning, if I'm giving, if I have a different MTU size in certain segments of my network, this could be a performance problem, right? Like, actually, so when I worked at Sun, I was a kernel tuner. Right, I worked deep in the Solaris kernel, and I learned so much about expectations of data chunk size and how, yes, you can feed it a bigger chunk than it was expecting, but that takes 2 cycles, not 1. And so we've lost speed. And so even in the network level that way, right, we have MTU sizes, we have mismatches in data size, we have mismatches in number of channels, we have, like, depending on what medium we're in, right? There's lots of different ways that the network is fully optimized. Or did we just plug it in and it worked? Did we optimize it for this application, knowing that its average packet size is X, rather than just hoping for the best, right? Are we truly tuned? Again, I'm going to use my example of racing. Are we truly tuned like an F1 car?
Yeah.
Or did we just drive off the lot, right, and think we were going to race in the big leagues?
Okay. Obviously, APIs are the connective tissue of today's banking systems, but what common interoperability pitfalls do you see slowing down the transformation?
Well, yeah, I think one of them is the mass number of APIs. The average enterprise today has more than 5,000 APIs in use inside their company. Like, let that sink in.
Wow.
It's a lot, right?
It's a lot.
I say API is the new IoT.
Oh.
Right. So, right. Years ago, it was you have a billion devices that you don't know what's on your network. Now you have a billion APIs that came sometimes with those billion devices.
That's right.
That you don't know what they're doing or what they have access to. Frequently, products are shipping with APIs on them that you're not aware that are active or in use or capable of use, that I could actually talk to your lights out manager and with an API and get it to do things. You just never thought of it because we're not using it that way, but it's on by default. So API represents a couple of really fascinating pieces. One is the security part. Like, what do I have? What's it vulnerable to? What's moving on the wire? How do I deal with those APIs and their vulnerabilities? Then you have the vulnerability of the API itself, right? How is it written? What is it capable of doing? Largely, most API systems have 0 identity models, right? You're just an API transaction. That's all. There's not levels of API transaction. And that can become a problem because you can't, like, zero trusting API is a whole new thing that we're all exploring, and how are we going to provide that? But traditionally, it's just been API. That's all. And then in the last piece, we have what's also more important to the business, frankly, is how fast is the API? How efficient is it compared to this method or this method or this method, right? Because if we're doing, especially financial, we're doing these transactions API-wise, every microsecond is money, right? So again, we're back to measuring it with money. Measure the speed, the efficacy, how much time do we spend doing this, right? All of that should really be the thing. Like if you've got man hours in doing this every day, then measure that with money. Don't measure that with these other artificial things, right? Talk the business speak, so that when you can go back to your upper management and say, look, we lost $1 million. Some of that's man hours, some of that's whatever, right? But we need to change this so that we can save this many dollars.
I kind of hate to put you on the spot, but can you share a real world example where poor API integration caused unexpected problems in a financial app environment?
Yeah, absolutely. So there's always that conversation of do we build a bespoke API for our application, or do we buy an API that's already available?
Right.
This becomes a real sort of fundamental problem as we APIize our applications. And really, I think the boom of it happened, and this is where the story centers, is where whether or not everybody in computers has realized it, but the medium that we're talking on, at least I'm on a laptop, is dead. This is over. For my standard consumer, it is a phone or a tablet, right? Almost every transaction that's happening these days is off of phone. And so as we made that transition, we realized like painting a web page on that little tiny screen is probably not efficient, right? So using standard web didn't work. And so we started to build these apps on the phone. And as we did so, they're all powered by APIs. And you know, one of the horror stories from a quite large financial that was one of the first to that market, so we're talking a few years ago, right? This is not modern, was they didn't understand the impact. It wasn't about the amount of traffic per se, meaning the size of the package. Transactions are very small in API, right? It was the number of available sockets coming into their system. They would run their socket pool dry because there were so many users trying to interact with the API all at the same time that you would starve for sockets, fall over, reboot, and then it would come back up and happen again. So it was this constant, right? And they hadn't considered their application vendor was like, this is not a problem we have. We have like a, you know, like a 7-digit, socket availability. We're not having this problem. Or they have a cluster, right? We have 20 servers back here, so we can take all the sockets you care to. It was happening upstream, and the network infrastructure was not able to carry the sockets through the NAT, right? Their NAT device was failing them. And so it busted them. So really, to me, it was a story, and I was involved in it as one part of the vendor in their scope. And really, I think it kind of came down to not looking at the application and its infrastructure holistically. Like, what do I need here and here and here and here and here to be successful?
Okay, compliance seems to evolve almost as fast as the tech stack. How can financial IT teams future-proof their for regulations like the GDPR, PCI DSS, or PSD2?
I think that one of the most critical things they can do is absolutely probably have a dedicated staff member who can understand the regulations. The biggest thing I've seen in compliance problems around the globe has been they don't understand what it actually says, what is actually required to comply. Instead, they take these sweeping ideas, just like with GDPR. I'll give you an example. They'll say if you have a hosting facility or something that's in America, well, we can't do that. It has to stay resident here. And the answer isn't that simple. It's what data is hosted there, not all data, right? And so they make these sweeping ideas about what it means. And I'm like, well, what if no public data ever leaves your premises? Well, we still can't talk to America. I'm like, that's actually not what it says. Like, it's not. And so it's to have somebody who can bring you to the reality of how can we do what we need to do and be compliant, rather than just blind adherence to a concept of this compliance, whatever it is, right? For cryptography or for observability or logging, right? And once we understand what the ask of the legislation actually is, now we can apply that and say, how do we do that quickly, securely, maximum uptime and efficiently, right? Do we have one system that maybe logs all of these functions at once into one brain, and then we can extract from that what we need to know from a logging perspective? Do we, right? And so again, it's about thinking about the whole process though, right? So when you say we're going to build an application that's going to be X fast, X usable to our users, it also has to be, right, data resident in these places or compliant with this encryption standard, or, right, that becomes the requirement up front. And then we build back through it.
Okay, what's your perspective on cloud misconfigurations as security risk? Are they more, is this more of a tech problem or a people process problem?
Well, it's almost always a people problem.
Almost always
I think cloud misconfiguration and cloud are the same word. And I believe it really kind of comes out of that concept we talked about a little bit ago, where I end up with the AWS team and the Azure team, right, and the Google team, and right, because they all work differently, and I have different teams trying to adhere to a single standard in 4 different languages, if you will, and it always ends up in a well, we configured it the Google way, but that's not mean the same thing as it meant for the Azure way. Right. And suddenly one of them is askew. So really, I think, you know, part of that is the tools, the tech. And so what I mean by that is if we have a common way to view our applications and data across wherever they are, right? They just look at, it's an application. The fact that it's hosted somewhere is not relevant to the console that you're looking at. That's the first one. And then the second one then is those compliance standards need to be reported on. Those configuration standards need to have some sort of an inventory of this is what they are, because they drift, right? Like an AI model, they drift. People have made a change to make this application work, you know, made a change to do something over here to make that work better. And suddenly, you know, where we thought we were is actually here now because we drifted, right? So we need to be able to understand and track that drift as well.
That's fascinating. Okay, and balancing scalability and security, where do most financial institutions get it wrong in the cloud?
Yeah, it's actually app development or application acquisition, however you want to phrase that, outside of structure. And it's true of all companies, not just financials, but sometimes there's more at stake, right? It's understanding that I might be manipulating data at some place, at some provider, in some GPT model, and it's not safe there, right? As useful as ChatGPT can be to say, here's my data, write me a financial model for this stuff. It's pretty easy for me as an attacker to get that data out of it. I just ask it because it knows. You told it, right? And so but we're not always cognizant. It's not malicious or even lazy. We're not always cognizant of what the boundaries of that data actually means. And so I think that's often is this sort of like slop that happens because we're trying to get the job done. Right? Like, I don't think people do it in any way other than I just need this done. And I need a thing that does this, or I need a system that's not offered, you know, from corporate. This does it for me 10 times faster, and we can process 80 more loans a day, right? And make X dollars. And the potential risks of what that might mean are not in their scope, right? That person's scope is closing loans.
Right.
Risk to that's somebody else's job. That's risk, right? And I think that's where companies have to, you know, everybody always says be tighter and control it more. But truthfully, what I say is that security and network need to partner more with the business, because this is clearly, if it's closing loans faster, just in our example, this is a business problem.
Right. So
it's my job to help let them do what they need to do to make more money, but do so safely and within the confines that we must adhere to, like, you know, GDPR and, you know, right. and whatever, aside from our own standards, the court, right? Because a lot of times you're doing that and it's not in, like, you're not going to pass an audit for having done that, right? But the person doing it, putting the responsibility on them to say, you had to think of all this stuff, it's not their job. right? Their job is to close loans or do trade or whatever they're doing, right? Your job is to provide them an avenue to do that quickly, safely, securely, simply.
Okay, with AI workloads entering production environments, what are the new security implications for data movement and access controls?
I think they become substantially more complicated. AI was not, LLMs specifically, were not engineered to understand that you do not have access to this other data. That's not what they were built for, right? And to give you just maybe a little sample into sort of like how their brains work for a layman, hallucinations, everybody always laughs at the things it does that are crazy, right? But if it didn't hallucinate, it wouldn't be useful. It'd just be a database, right? So the hallucinations are part of the creativity component that allow the AI to be useful, to make associations that we couldn't think of. And so the same thing's true with data, though, and that's why I tell that little story, is I've placed all of this knowledge into this framework and then given it an overseer that's meant to be helpful. It's meant to tell you answers. Sometimes it makes them up to tell you an answer. But the key is then securing that data inside there is nearly impossible, because the agent's going to always try to do what will answer questions for the right for whoever's given it the prompt. What we have to do is we have to put around that then a series of guardrails that is also probably an LLM that understands the language of an AI, all the pieces it's going to go through as it processes data. And then it can process in natural language what the prompt said. What did it mean? What's it going to cause to happen if I do this prompt? And does that person have access to do that sort of thing? And then pass the prompt on, right, to the AI.
So what advice would you give to a CIO trying to convince his or her board to invest in modernizing app infrastructure now rather than later?
Dollars. Just like I said, measure it in money. Measure it in money. If you can come to them and show them we're losing $400,000 a minute because we're not running this app infrastructure, and I don't want to move from here to there. I want to move from here to there, right? We're gonna increase our ability to transact, for the future. We're gonna consolidate these functions, which will save us this much money. That will save us this much time, right? That's how I would approach it. Is this is an opportunity for the business to grow, rather than expense of operation.
Okay, this is kind of in the same vein, but you've worked across enterprises, startups, public sector. You've got an amazing work history. What lessons translate best to today's financial IT landscape?
Yeah, remember. I guess first one I would say is remember the goal.
Remember the goal.
That's often what I see in startups. Is they forget what we set out to do. What was the problem we were trying to solve for the customer? And before we pivot and do something different, does that solve the problem? And then remember that the problem we're trying to solve comes with problems, right? So if we implement this new system, we need expertise, we need headcount, we need, right, this other support structure that's part of it. And now that becomes part of the problem. So now our problem is to deliver this app quickly, securely, safely, always up, and accommodate the workload it will generate on the team. That's the problem, the whole problem, right? And always keep that in mind. Like, what is the purpose of this? The purpose of this is to do that, whatever it is, deliver this application quickly, whatever. And keep that as a mantra for the project. Because if we're implementing something that doesn't do that or negatively affects that, we're working counter to the business. We're trying to solve a business problem. So make sure that everything we're doing is in line with helping the business.
Okay, we've only got a couple of minutes before we get to the Q&As, but I want to ask you this one. It's kind of future. So financial institutions who want to make one meaningful change in the next 12 months to prepare for AI-enabled workloads, what should they do?
I would say begin a process of consolidating vendors and solutions that are not built for the future. If you're working with companies that built applications, I'll just pick on WAF for a second, right? It's a 20-year-old technology based on an open source code. It is not prepared for AI.
No.
Right. So begin to look for companies that are maybe you look at them today and you don't fully even understand the approach they're taking, but they're looking at that, not at this. Right. Because so many companies have solved problems that we had that generated new problems that they don't solve. Right. And so really look for something that approaches your problem holistically, right, and completely. Because once we get that, the key is AI is going to bring a bunch more problems with it, right? No matter what we do, it's going to bring a pile of new problems. You got to get some of the problems you already have settled before you get a pile of new problems. And that's why my advice is to look for pure play platforms, things that are actually all integrated together, not separate products talking to each other, not 9 vendors to do 6 things. Look for how can I make this easier to use, simpler to understand, right? And requires less workforce to deal with because we're going to be dealing with AI.
Okay, man, thanks. That was awesome. Guys, I want to let you know, remind you all that you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's see. We've got one here from Al who's wondering, Jameson, modernization projects can be expensive, especially in the financial sector, and the time before any measurable impact is seen can be long. How can we shorten the time to ROI while controlling the cost of app and infrastructure modernization in a hybrid cloud environment? Man, that was a long one.
It's a long one, yeah.
Did you get all that?
This really comes down to, one of the points I've been stressing, all along, which is money. If we measure, this was the cost impact of making this change, and we have an expected amount of, more money made, more money saved, whichever metric we're following, I would build an intersecting line, right, that I could report on. Every quarter, we're here. Next quarter, we're here, right? We're increasing or decreasing whatever by X percentage. You got to use numbers that business people understand, right? So pretend you're teaching math to an 8th grader, and then I couldn't resist that one. But yeah, really lay it out simply. The reason we did this was to change profitability, expense, cost, uptime. So measure it and lay it out that way to them. So instead of saying we're going to save, in the end, we're going to save $8 million. Say we're going to save, 1.1 every quarter until we hit the final goal, and show that we're achieving ROI on this path.
Okay, here's one from Sunny who's wondering, how should enterprises prioritize workloads when deciding what stays on-prem versus what moves to the cloud?
Oh yeah, I feel a little bit like I'm stuck as a broken record. It's money. Yeah. It really comes down to money, because we can secure workloads in both places pretty equally. We can, all that stuff is not really the metric. It is how much does that compute cost you over the life cycle. That's really what it comes down to. It is knowing the consumption model of the cloud you're going into, knowing the truthful compute amount that it will generate, and then measuring that against buying your own or having your own private cloud, right, where you have control over, like hosted at Equinix or somebody like that, right? It comes down to that. It's really about what does it cost us to do versus what does it cost us to consume.
Okay, I was thinking we had another one here, but it looks like that's all the questions we have. Wow, we've got a bit more to go in this session. I want to announce the winner of the drawing. But first, I want to thank Jameson Utter. That was just awesome, man. You are a pleasure to work with.
Thank you. Thank you. I'm glad somebody lets me spout my opinions to an open format about this stuff.
Well, I love hearing them, man. Thank you so much. Okay, folks, let's see. It's time to announce the winner of our digital drawing. Congratulations to Daniel Garcia with Gates Corporation. You have won a $300 Amex gift card just for showing up. Our team will be in touch with you on how to claim your prize. And that's it for today's summit, folks. Future-proofing your app infrastructure in the AI-ready hybrid cloud era, Financial Industry Edition. Many thanks to Jameson, and a special thanks to 810 Networks for making it possible for us to have this event. We couldn't have done it without them. And folks, we'd love to hear your thoughts on this event through the exit survey. Your input shapes what we do next. And be sure to follow us on YouTube, subscribe to our newsletter, and connect with us on LinkedIn to stay in the loop for upcoming events. Thanks, everyone, and have a great day.